Hello everybody. Today I am going to talk about Ethernet from my class Computer Networks. I am Professor Dr. A.K.M. Fazlul Haq, Head Department of Electronics and Telecommunication Engineering. So today this topic is very important, and Ethernet will have some brief description about what is Ethernet, what is the function of Ethernet, what is the application of Ethernet. As you know, actually Ethernet is a LAN technology, and it has some provisions to extend the informations for local area networks. If we define Ethernet, so it's actually the certain type of local area network. So before going to details, I would like to say first computer network topology if we have. So we know there are two types of topology. One is physical topology, one is logical topology. Physical topology, we can say how network devices are connected to each other. Suppose bus topology, star topology, we'll have some description later. But logical topology means how the informations are being exchanged or being communicated among networking devices. So this Ethernet is evolved this information, how in the LAN data is communicated or data is shared between the devices. So this is the main context of this chapter. So if we say this Ethernet TCP/IP, in this configuration, if we see there are some header of TCP, header of IP, there are some figures here. Layer 7 also, it is compare IP data, Ethernet data here in this figure, and it is little bit described about the Ethernet structure. Ethernet, legacy Ethernet. Fine. This actually we'll have also description little bit later. There we can say 3 or 4 types of Ethernet. One is legacy Ethernet, one is fast Ethernet, gigabit Ethernet. So in the hub, if we use the hub in the network topology as a network devices, how information is being exchanged here. As you know, the first or second lecture I explained briefly about this. In the compare, if we say the hub actually, if we make the ping from the one computer, hub first transmits ARP, then ICMP. Hub broadcasts ARP, ICMP in all cases. So if at the same time, if it is not unicast, it broadcasts the information, and if the originator from the different sites sends the informations, there is some chance of collisions. Okay, so this is the drawbacks of the hubs, and if we use instead of hubs, we can consider switch or something others devices, so we can have the solutions, we can solve the problems from this collision problems. So this is actually the poor performance of hub based LANs if you consider legacy Ethernet. That means also we'll have the Ethernet structure, brief description about Ethernet structure. Okay, so if we consider here using switch, so unlike hubs, switch have some functional efficiency. He covers the information, he reduces the chance of collision because it has some speciality, because it unicast first time it broadcasts the ARP, and when it captured the MAC address from the different computers, so next time it doesn't broadcast, and ICMP it always unicast. So also the chance of collisions, because in one way, one-to-one information, so the chance of collisions is very limited here. But where the same topology, the poor performance, that means the legacy Ethernet was being used in hub inside the computer topology or computer networks. So there are some chance of collisions. Here, if we compare the use of switch and versus hubs in a LAN, because we know the passive hubs, if we say, there he has no provision to diagnose the information. That means it comes and it transmits. So hub, we can say it's a multi-port repeater. A repeater, it has input and output, and hub has multi-port. So that means it likes just repeater. It receives the information, it passes the information, but switch has diagnostic capabilities, whether the information will be sent or not, because it has some ports, it has some MAC addresses, and when first time ARP sends, it just reads the MAC addresses, and every switch port has MAC addresses. When next time it goes, then it sends the information unicast. So that means the performance here, if we compare this, but it doesn't happen inside the hubs. So the performance actually is better in case of switch compared to hubs. Backup algorithm, informations when there is some collisions. In the next chapters also will have brief description about it, but here I would say if there is some collisions, some devices, networking stations from the topology will stop some to refrain. He will refrain the informations because there is some times it will take to recover. So first time they will try sometimes, first time they will wait, second times also they will wait, third times also they will wait. The waiting time between this will be some gaps. Okay, so how these protocols or how information will be calculated here. There are some specific algorithm, backup algorithm will be informed here to remedy the situations. Multiple access, as we know, in this figure we say actually there are two types of here, the access, random access, multiple access. Multiple access again refers to carrier sense multiple access with collision detection, carrier sense multiple access with collision avoidance. So normally we can use the Ethernet uses this carrier sense multiple access collision detection. In 802.IEEE 802.11 it uses the code division this CSMA CA. So the CSMA CD is very important because first we have to understand what is CSMA, carrier sense, how the carrier is sensed, and carrier multiple access of course, and how it is the collision is detected. Okay. Normally if we consider a road, so before transmits what we say, if we go randomly, but it is better to see whether there is any traffic jam or something, anything happening in the road. So if we check this, after checking this, if it is normal, then if we go outside, then it would be better than previous. In the same thing happening in this data communication. First, before transmitting data, first the information will be sent whether there is some collision or not, or whether the channel is free. It is not doing by personally. All of the users, these channels between this, they are accommodating this, they are checking this. So that's why this is multiple access. So first time before transmitting informations, some information goes and check whether there is some collision or whether channel is free or not. If it is free, then the information will be sent. So this is done by multiple users. That's why it is called carrier sense multiple access. And collision detection, it doesn't means that whether after the sense is carried here and information goes, there is chance of collision against. So it just hears until the information reached the destination successfully. Okay, so it is happened like this. So this is it collision is detected or not, it is informed here. What happens if after that, what happens if collision is detected? Of course, there is some broadcast signals it generates all users. It is called jamming signal. Here in this figure it is mentioned here. Jamming signals contains the informations there is, yes, there is some collision in the channels, and it sends this information to all associated users. After that, these users will understand, yes, there is some collisions. So they will wait sometimes. When it goes again, they will try, again they will try. Okay? So normally backup algorithms here is used here. Question is how many times they will be waiting between this consecutive to waiting time. Normally there is some formula 0 to 2 to the power n into maximum propagation time. Now if we consider here maximum propagation time, so 1 unit time, and n equal to number of tries. If first try 2 to the power 1 into 1 unit, 2 unit time. Second try 2 to the power 2, 4 unit time. Third try n equal to 3, 2 to the power 3 equal to 8 unit time. So that means in this way the time is being changed. So backup algorithm satisfy these conditions. Okay. There are also some important things for behind this carrier sense multiple access collision detection. There are two types of strategy actually to send the information. One is non-persistent, one is persistent. So non-persistent strategy means if the channel is free, information goes. If the channel is doesn't free, information not goes. That means 1 or 0. But the persistent strategy is not like this. Persistent strategy is little bit clever than non-persistent strategy. If the channel is free, it doesn't goes immediately. He thinks again that there is chance of collision immediately. So he makes some probability theory. Okay? What is this probability theory? Suppose 0.2 probability he will send the information, and 0.8, that means 80% probability he will not send the information. When he apply this mechanism, there is some token number from 0 to 100, and he takes the token. If the value is less than 20, then he will send the information. If the value is more than 20, he will not send the information. So statistics says this performance is better than non-persistent strategy. So CSMA CD also use persistent strategy. So you would say in this way we can define. So this is the brief description of carrier sense multiple access collision detection. So in this figure the flow chart is defined here. Okay, so students, I think you will be understand, and you will see the books, some reference books from some others. Later when the end of this course I will have some suggestions, and in the course contents also you have some reference books, so you can see from their details. Collisions. So how can we say collisions? When collisions happen, that means there in the topology there are multiple users. If both users sends the information at the same times, there is a chance of collision. On the other hand, you can say two users on the different sides are looking, there is no collisions. Suppose I am 100 kilometers so far or 100 meters so far, we can say 1 kilometer so far. Both two end users are looking, there is no collisions. We send the information, but after a certain later, some places we can meet to each other. So this is collisions. Okay, so that means carrier sense is better, but you can't say there will not be collisions. Of course, still the collision is remaining. That's why collision detection is coming. Okay, to avoid the solution. Is persistent strategy, non-persistent strategy also have come here to avoid these problems. So we have to understand in which things, which part we will apply, which topology, which strategy, non-persistent or persistent strategy. So this is actually the collisions happens in this way. So there are some solution also, corresponding solution. If these collisions happen inside the channels, how can we remedy the situations? Okay, so there is so we can avoid the collisions. We can't say this is collisions free. We can improve the problems If it is 5% chance of probabilities of collisions, maybe we can reduce the number of chance of collisions. There are some using some modern or some existing techniques. Collision detections, also I explained here how collision is being detected here, because if there is some collisions in the channels, automatically it sends the information, which was so called, I said, it is jamming signals. So using backup algorithm we can maintain this, and the signal was jamming signal. Using jamming signal, all stations are associated, they will understand, yes, there is some collisions in the channels. So they will be alert themselves and they will wait some times to resend the informations. Okay. So Ethernet topologies, the very important some topologies here, as I mentioned earlier, there are some topologies, physical topologies and logical topologies. So if I explain bus topology, and this topology, there is some backbone network and there are some workstations are associated, and there is some limitations also. So what is the working principle of bus topology? Each computer or each station will send the information to other stations. Normally it can send, but it not normally unicast, it broadcasts the information. So that means it broadcasts the informations, again it will receive the information, also it broadcasts. So this is the normal procedure. If suppose here this first workstation want to send the information to third workstations or computers, all computers will receive the information, but the particular where the match the number IP or MAC or some other associated, only this particular workstation or computer will receive, other will reject the informations. So if I say normally the question is arised here, the bus topology from first computer to last computer. Okay. So if first computer originates the information, what would be the last position? Because in the bus topology there is a one last position. What happens inside this? Because there is, it is actually energy or power. It goes, again it goes back. So there is a chance of probabilities of infinite loops. So it can hamper the signal strength. So there are two terminators are seated by just besides these two parts. When the information goes from left to right, that means it covers all PC. Right to left, it covers all PC. But if terminator is there, it can vanish the signals. There is no chance to feed back the signals again here. So if I say what is the advantages of bus topology? Very simple, it's reliable, very simple topology, cost is moderate, troubleshooting is also very easier here you can. And if I say what is the disadvantage? Because you know from this topology, bus topology, the main problem is it broadcasts the information. You can imagine if at the same time all workstations try to send the information, what would be happens? Inside too much traffic. Okay? So too much traffic, the performances, the throughput can be reduced. So this is the main disadvantage of bus topology. Again I can say the star topology, this well-known topology, is very useful topology in the normally worldwide in the local area network it is used. And star topology, there is a central device. Okay, all workstations or all PCs are connected to this star topology using this hub or switch. That means there is some central control. If we add this some PCs inside this, there is no problems for other computers. We can remove one computer from here. Even if one computer is lost here, no problem for other computers. So very easily we can communicate. So this is also very useful and this is very simple, reliable, cost moderate, troubleshooting is also easier here. So disadvantages, if I said before, if computer fails, no problem. If we add computer, no problems. If we remove computer, no problem. So what is the problem? Very simple here. If the central hubs or central switch, central device fails, then whole network fails. This is the main disadvantage here. We have also ring topology here. If we say it's like a ring and each computer is associated to each other. Every computer has successor and predecessor. Every computer knows to whom he is going to send the information is from where he is receiving the informations. Problem is, if we want to send the one computer to other computers directly, we can't send. It goes clockwise or anti-clockwise. First, second, third, in this way he has to go. There are a lot of problems here, it may be arised here. What kind of problems? Suppose one PC fails. We think the whole network fails. If one PC we can add, we have to change the information, successor, predecessor, we have to change. So if we remove the computer also, it will hamper the information, so it will hamper the network topology. So this is also disadvantage. Advantages means it monopolizes the system. That means there is no client server. Every computer has the privilege. That means if one computer trying to send the information, he can send because there is no controlling here. What's the working principle here? If one computer want to send the informations, there is a token is rotating here. Okay? So one computer want to send the information, he has to take first the token. Token will be captured by one computer. Then his will be privileged. Okay? After that, one computer will send the informations. Okay? When during this sending the informations, other associated computers are silent. Because why? Because they have no token. They will have to silent. After that, when information sent from the receiving end, there will be one acknowledgement. The sending information, the sending computer will understand, yes, my information is received. After that, the token will be free inside the circle. Then again, if one computer want to send the information, again he will try to capture the first token. In this way, this information will be communicated between all networking devices or computers or workstations. So there are some casting here. I would say unicast, multicast and broadcast. As earlier I described, you can see this from this figure. What is unicast? That means one information just goes to one computer. Okay? There are a lot of peoples here or a lot of computers here. If the information is communicated to particular one PC, we can say this is unicast. Multicast, some of the groups of this information are carrying information. Some of the computers in a group, they are receiving the information. This is actually multicast. Broadcast, all users are here, they are receiving the same information. That means whether you will receive or not, or it is associated or not, or this information is needed or not, but you will receive these informations. That means one sender and there are multiple or many users here, all of the users or all of the stations, the information will be received by them. This is actually broadcast. From this figure, we can say there are some information here about unicast, multicast and broadcasts. Ethernet frame format is very important because when this information goes, this frame has some structure. First, if I say preamble, okay, so that means this preamble is its synchronization, okay, bit synchronizations or to sending and receiving, it has some special, some bytes. Then destination address, source address, type, data, padding, it has some limitations from, you can say 0 to 1500 bytes, there is some limitations. If we want to send the information more than this, there will be overhead, but if less than this, suppose the limitation is you can't send less than 46 bytes, but my information is less than 46 bytes. So what should I do? Is it like this? Will I not be possible? I cannot send the information? Will it be like this? No. If it is suppose 26 bytes your information, so there is some special places you can add more 20 bytes. So total 46 bytes. So that means